Today we will discuss curves in space. Let this C is the curve, and towards this direction tangent is here, and towards this direction t cap is unit tangent vector, and perpendicular to this tangent n cap, this is principal normal, and n cap is unit normal vector, and perpendicular to tangent and principal normal. Tangent and principal normal, we have binormal, and in binormal direction b cap is the unit vector, and plane between this b cap and t cap is known as rectifying plane. Similarly, plane between b cap and n cap, this is normal plane, and plane between tangent t cap and n cap, this is osculating plane. For every curve, for every point of curve, there exist three mutually perpendicular lines. These perpendicular lines are known as tangent, normal, and binormal. At every point of curve, there exist three mutually perpendicular planes: osculating plane, rectifying plane, normal plane. These planes can be determined by pairs of these perpendicular lines. We have this rectifying plane, normal plane, and osculating plane. Now, tangent at a point and arc length. Here, point P0, P0 is the initial point at time t is equals to T0. After a time t, this will be at point P, and the neighboring point is Q, and position vector is r vector t plus t, and position vector of P is r vector t. T is parameter, and delta r, this is called PQ. At point P, we have a tangent, and on tangent, let us take a point X. Let RT, this is position vector of P, xt I cap, yt j cap, plus zt k cap. When Q tending to P, then this delta R becomes R t plus t minus position vector of RT. This parameter t takes different values, then the point P traces occurs in a space. That means P moves in a space. Delta t is scalar, and therefore delta r oblique delta t will be this one, because delta r equals to this one. When this point q tends to p, then delta t tends to 0. According to delta t tends to 0 when q will be at point p. The direction of this q will be same at this direction tangent. So we can say direction of this q, if q tending to here, then direction will be same as direction of this tangent. Therefore, limit q tending to p, delta t tends to 0, delta r upon delta t, this exists. Now, this will be dr dt and denoted by r dash. Now, this arc length p naught p is delta s upon delta t. So we can write in this way, and this arc ratio of arc pq and chord pq will be 1. Here this ratio will be 1 and delta r delta t. And our previous knowledge, we have this one, q tending to be delta t, delta s delta t equals to ds dt, and this one will be dr dt. Their position vector is r. So we can write in this way, or at parameter taking t, then position vector will be rt. After integration this one and taking limit from t naught to t, because initial point is t naught and the reaching point at this is t. Therefore, after integration and taking proper limits, this is the arc length. So we will use this formula for finding our arc length of an arc. So as equals to t naught to t square root of x dot square plus y dot square plus z dot whole square dt. The set of unit orthonormal triads forms a moving trihedral at point P, where Tn is 0, n dot b, b dot t. Similarly, if we taking here cross product, the vectors t and v are, this vector t and b are called fundamental units vectors. These are fundamental unit vectors, and planes, as we have discussed, these planes, oscillating plane, rectifying plane, normal plane, associated with each point of a curve are called fundamental planes. We can use these symbols as per given in our question paper or accordingly our question. These are some questions. We have an example. Find the unit tangent vector at t parameter t, and unit normal vector nt for circular helix. X equals to a cos t, y equals to a sin t, z equals to ct. E is greater than 0. This is a circular helix and point x a00 according to this one. So position vector, let position vector equals to I cap plus a sin t j cap plus ct k cap. Here I, j, k, these are unit vectors along x, y, z direction. Norm of these one unit vectors is 1. After differentiating with respect to this position vector with respect to t, we will obtain this one. T is parameter. A cos t, we know differentiation of cos t, that is minus a sin t, and according to here. Now we will obtain norm or length of dr dt. So norm, as we know, square root of minus a sin t whole square plus this one. After simplification we will obtain, because sin square plus cos square, taking a as common, so here it will be only a square and c square, so this will be square root of a square plus c square. Now unit tangent vector will be denoted by t. So this is r dash t upon norm or length of r dash t. After simplification, this one and simplification we will obtain, because this is constant c, a and k, these are constant here, so differentiation of this one with respect to t, it will be 0, so t dash t, this one. Now norm or length of t dash t is this one. After simplification, because cos square and sin square will be cos square, summation of cos square plus t plus sin square t will be 1. So after simplification we will obtain this one. Because this is norm or length, so we are taking positive symbol, and unit normal vector will be given by this formula. We are using this formula directly in our practice questions. T dash t upon norm of t dash t. On putting the value of t dash t in both this here, so this is the simplification, and nt, unit normal vector, will be this one. Nt lies in horizontal plane as k component is 0 here. So normal vector lies in horizontal plane. Now we have to obtain arc length of the portion of the circular helix. If we draw a curve of x cos t, y sin t, z equals to t, from t equals to 0 to t equals to pi, because z is a parameter, z equals to t, z equals to t is a parameter. If we draw a curve in 3 space, z is not constant, so we will obtain a figure like helix, and we have to obtain arc length of this portion from t equals to 0 to t equals to pi. As we have discussed, we will obtain arc length. So it is given here, we have to obtain the arc length from t equals to 0 to t equals to pi for this circular helix. And helix, because we have z equals to t as a parameter. So if we draw, so we will obtain a helix that will be circular type. So circular helix. Now position vector of x equals to cos t, y equals to sin t, z equals to t will be here. Cos t I cap plus sin t j cap plus t k cap. And we are considering here I cap, j cap, t k cap. These are unit vectors along the direction of x, y and z respectively. And taking differentiation with respect to t, as here t is parameter. So taking differentiation with respect to t, we will obtain this one. This is one. And norm or length or magnitude will be this one. After simplification, because cos sin square t plus cos square t is 1. So here this thing will be 1 and 1. So under root square root of 2. Now the arc length of the helix of the portion of circular helix from t equals to 0 to t pi. So limit, lower limit is 0, upper limit is pi here. So norm of r dash t dt. After putting this value, this is r dash t is 2 square root 2 and dt, and integration gives us pi root 2. This is the arc length of the helix from t equals to 0 to t equals to pi. Now we have some practice question. Obtain the equation of the circular helix r equals to a cos t a sin t bt, and t lies between this one. A is 0 here, greater than 0. Refer to S as parameter and show that the length of the complete turn of the helix is 2 pi c. C is given by this one. This is practice question. You can solve easily if facing some problem or difficulty or difficulties. Then you may comment, and then we will provide you complete solution of this problem or any other problem or problems as we have discussed. Try to solve, and if you are facing some problem difficulties in understanding, then you can comment directly. Thank you for watching.